Okay, really simple. Make a 3 by 4 matrix. So 1, -1, 1, 8. 0, 2, -1, -7. 2, 3, 0, and 1. Okay, make sense, guys? And I think I labeled it row 1, row 2, row 3. I'll just call it ABC because that's what the other teachers do. So whatever, same thing. So your goal is to combine these rows somehow. I think what makes sense first is to do 2A plus B. Why do you think I'm doing that? What would that accomplish? If I multiply A by 2 and add it to B. Yeah, actually, I think I kind of make it worse, actually. I'm going to take it back. So it's okay to change your mind. I'm going to do B plus A instead. Okay, what will that accomplish? Well, what goes away? If I change row A, if I add it, you should get 1, 1. What's the third number, guys? Yeah, and I want a 0 there. Because what's our goal? I should have mentioned that first. Our goal is this, right? And I'm going to put these little squiggly lines. Those are just other random numbers in the last column. And that's what like X will equal something, Y will equal something, Z will equal something. Those little squiggly lines are those somethings. So I do want the first row just have a 1 in the first column and then a 0, 0, then some other number. Or it could be 0, I guess, if X equals 0 or whatever. That's what I want. If I add B to A again, I should get 1 here as well. Okay, does that make sense what I just did? Okay, cool. And then I'm not going to really touch row B or row C right for now. So I'll just do this. Okay, so most likely, trying to think what would make the most sense here. I could probably try getting rid of the second number in row A. I could probably try doing that. So this is B plus A, right? That's what I did over here. Over here, let me do C minus 3A. Okay. So by doing that, uh, just to kind of make my life a little easier, I'm just going to write down here. That's C. That's 3A. 3, 3, 0, 3. Okay. So, and I'm going to subtract. So we get -1, 0, 0, -2. And does that make sense?
Why does that go into the A1?
So I want to change it. I chose to change it. It's your choice. I could change the third row if I wanted to. But I chose to change the first row. It's up to you. Okay. And 0 to -1 and -7. Okay, I'm just trying to be very careful here. I'm going to swap um, row B and row C. So I was going to do a swap. So you're allowed to do that. It's totally legal. Yeah, kind of. Okay, feeling good about that. Okay. Again, this is our goal. Then I'm going to get rid of the 2 in the second row. So most likely I'll do 2A plus B. So 0, 3, 0, and -3. Then let me get rid of, let me get rid of the 2 in the third row. So I'll do 2b minus 3c. So I did 2b minus 3c, that will be 0, 0, because it should go away. That should be 3. And negative 6 minus negative 21, that should be 15, I think, if I do it correctly. Yeah, negative 6 plus 21. Yep. And then lastly, I'm going to do negative a, 1/3 b, and 1/3 c. I'll get 1, 0, 0, 2, 0, 1, 0, negative 1, 0, 0, 1, 5. And so your answer is 2, negative 1, and 5. And maybe I could have done it a little more efficiently, but that's how it goes. And if you check and plug in each equation, it should work itself out. So that's a quiz problem. Hopefully that makes sense. Okay, and the video I think would make sense, so watch it again if you need to, or I'll save as a screenshot. Here we go. Also, make sure you know how to find the determinant. Guys, quiet, please. Of a 2x2 matrix. Say I want to find the determinant of that. That's just 1 times 4 minus 2 times 3. So 4 minus 6, negative 2. That's all. Very simple. It's the formula goes like this. Sometimes it's written like this as well, like these kind of looks like absolute value symbols. Just AD minus BC. That's simple. That's all. So we're okay with that? Cool. And the last one, it's just a simple combine stuff with matrices. No matrix multiplication, be like more like 47. Like A, distribute the negative 5, distribute the 4, add them up. That's all. Right? So there's a quiz. All right. So if you want to do the quiz a little later, you can. Let's talk about calculator questions. Sorry, non-calc questions. No, that's what's on the quiz. Okay. Let's do. Give me a sec here. I might have to pull on my device so I don't go back and forth. Okay. Hold on, sorry. Once I'm just gonna Dropbox 23, 24. Because I don't want to show the actual questions, but to give a little taste of what. Wait, what the heck? Hold on. Ah, there it is. Okay. There it is. Cool. Okay. So yeah. I think something like 3 is a good one to talk about. Now, someone asked him, he asked about the formula sheet. Let me show it to you guys. Here it is. I'll put in Schoology as well. Everyone gets this. Actually, hold on. Make sure I'm. Yeah, I think everyone gets this. Yeah. Yeah. So yeah, you guys should know the basic trig identities, sine, cosine, whatever, right? And the double angles right there, some difference formulas, Pythagorean trig identities, law sines, law cosines, area of a triangle. For Heron's formula, do you guys know what A, B, and C represent? What do A, B, and C represent Heron's formula? What do you guys think? Let's find the area of a triangle. The sides, and what is it? And S is just some other formula. It's called a semi-perimeter because you have all of them divided by 2. So easy peasy. Exponential log stuff, that should be fine. The one part, actually, everything that you need is there. Because I remember some of you guys got tripped up because they didn't provide all the formulas, but I think just realize the finance formulas. Some of you guys are doing some weird stuff. Some of you guys are using this one, it made no sense. You could use this, but of course, this is for continuous. But you could do a variation of it, like you do change the R to a K, but So you guys get some really weird stuff. You want to use this one instead. Where K represents every time you compound per year. Like if you compound monthly, that can be as well. That's for more general exponential growth or decay, like it's growing by 10%. 1 plus 0.1. So it's decaying by 5%. 1 minus 0.05. Easy peasy, right? Not that hard. Matrices, no formulas. And we'll give you a blank unit circle that you guys can fill out right before. But you know what? Maybe just right before, just look at it and then copy it. So you'll be fine. Yeah, because I'll show you how that could play a role. Hold on. Let me pull up some of the questions here. Yeah, it could play a very, very tiny role, just a very tiny role. But let's go to the problem right now. This one right here. Okay, that's gonna be 2 sine theta cos theta. That's a cosine squared theta minus sine squared theta. Or there's actually 2 variations of it. 2 other variations of it, sorry. This one, I always forget this one. What's that one gonna be? Oh, 2 tan over 1 minus tan squared. Yeah, 2 tan. Come on. Okay. So what are you gonna do about this part though? How do we deal with that? What quadrant is that in? Good. Yeah. And cosine. Ca. Where's the 5 go? Hypotenuse. And then that'll be negative 12. Why negative? Going down. Perfect. Thank you, Kyle. So then just plug away. 2 times negative 12/13 times 5/13. Clean it up. You have a calculator you can use, right? Because this is non-calc. Well, I don't know if we put this in a non-calc. Maybe I'll give you 4 function then. Anyway, it's negative 120 over 169. This is clearly not unicircle at all, just plug in. This one right here, cosine is 25 over 169 minus 144 over 169. That's negative 119 over 169. And lastly, two negative 12/5. 1 minus 144 over 25. Let me clean it up, I suppose, right? Negative 24 over 5 over negative 119. Flip it. $119. I don't think you do anything about that. Yeah, I think you just leave it. So it's kind of a weird number. It's 120 over 119. Yeah, that's your answer. So, okay. So that seems okay. We're okay with that. All right. Another thing I forgot to talk about with you guys. I forgot to talk about solving trig equations. That will be actually in the I think the calc portion. Yeah, I forgot to talk about that with you guys. So say I tried to do this problem, right? What would you guys do for this one here? What would be your approach? What would you want to do? Should I cross off those sine thetas and those twos? Don't. You lose the solution. Move everything over to one side first, then factor out. That'd be my recommendation, because you will lose an answer. So factor out 2 sine theta. So sine theta equals 0. And cosine theta equals 1. Where does that happen? Now this is unit circle stuff, but you have a calculator, so it's fine. Where does that happen? That's at 0 and pi, right? And that's at 0. So just say 0 and pi. Does that make sense? And then here, how would you handle something like number 9, by the way? What would you do? Yeah, just like factor, right? Think of like x. Yeah, totally, 100%. So that'd be shoots. Let me think. +1, +1. Yeah.
Six would be 0 plus.
No, because it's not general. It's confined in that interval. Yeah, and sine theta equals -1. So theta will be 3 pi over 2. Theta will be -1/2. What's y? Y. 7 pi over 6 and 11 pi over 6. So those are your answers for that one. Hope that makes sense. Okay. All right. But non-calc questions. What else can we talk about? Let's look at graphs of rational functions and logs. Let's get into graphing right now. Okay, actually, let's do this one first. I think this is a good one to do. Well, you may need. Actually, I'm not sure if I'll ask you to sketch something like that. I don't think we'll do that one. Let's do this one instead. I like this one better. Okay, factor on x. X squared minus 4x plus 3. X minus 1, x minus 2. Now, when those cancel, what does that mean when those cancel? And Jan, keep your phone away. Thanks. There's a hole. There's a hole at 1 comma something. And how do you find the y coordinate goes to the hole? You plug back in the simplified form. If you do that, you should get -2 up top and -1 down below. So it's 1 comma 2. There's a hole there. Okay. Asymptote is at x equals 2, vertical asymptote. No horizontal asymptote because the top has a higher degree than the bottom. You will have to do some sort of division. I'll do synthetic. So I'll put a 2 on the outside. That's x squared minus 3x up top. So it's 1, -3, and 0. 1, 2, -1, -2, -2. So it becomes x minus 1 minus 2 over x minus 2. So your oblique asymptote is y equals x minus 1 because the whole point of it is to see how the ends of the graph behave. When x gets large, that fraction 2 over x minus 2 just goes away. So just y equals x minus 1 is your oblique asymptote or slant asymptote, if you want to call it that. Y-intercept is easy. That's 0. 0 comma 0 if you want to write like that. X-intercept is where it makes the top 0. 0 comma 0 and 3 comma 0. Sweet. Domain is all real except 1 and 2. So you got that. X minus 1. One comma 2. Hole there. And I think that's it. Yeah, then you can just do your graph. You'll be fine. And you really don't need more points, guys. This is good enough. Because what's the whole point of the asymptotes? You want the graph to lean up against it, right? The ends of the graph behave like y equals x minus 1. They're almost the same thing. The ends of the graph are like y equals x minus 1. They have a linear nature to it. And the vertical asymptotes just shoot up or shoot down depending on what side they're on. I can do a sign chart, but it's all good. So yeah, that's what we do. So you could practice another one on 63. I won't do it. Let's talk about a log graph. We'll do this one here, 91. Okay. So if you think about it, compare it to this. So x equals 3 to the y power. And again, I'm recording this. I have strong suggest you guys watch this again if you need to. So if I do the parent function where I don't have the -2 involved, and I'm gonna plug in make y my input. Okay. Now if you shift 2 right, you're gonna add 2 to these, right? So I actually will shift this. Kind of the cool thing here, I can actually do that, right? Kind of neat. There we go. I did my shift. Actually, I don't know why I've never done that before in Zoom. It's kind of nice. So your vertical asymptote's right here. X equals 2. X-intercept, now it's at 3, 0. Range is all real. Domain from 2 to infinity, non-inclusive, right? Increasing the whole time on the interval. Decreasing none. End behavior. As x approaches 2, I'm a little more technical because I teach calculus, but if you approach 2 from the right side, the little plus means from the right side. If you approach as x approaches 2, it's fine. You can have the superscript. I'll live with that. But y is approaching negative infinity. As x approaches positive infinity, what's y doing? It's going up forever. So that's what I'm looking for that problem. Step by step. Okay. Let's solve multiply matrices and writing upon an equation. I think we're good. Okay. Let's look at 66. That's a good one. Your factors would be this, right? But we don't know the leading coefficients. They say that this is true, that y is less than or equal to for all values of x. The degree is greater than 1. Okay, obviously I have that all set. That's interesting. Okay. So you have 1, 2, and 3. So the graph could look like this, right? How can we guarantee that y is always negative? Because right now, what's y? Y sometimes negative, sometimes positive, right? Positive here, positive here. So we have to get a little creative. You have any thoughts that we can do? What was that? Not odd. We have odd degrees right now. We should get even degrees. With odd degrees, guaranteed one's gonna be pointed up, one arrow's pointing up, right? So let's do even degrees. So it means that I might need to double up some of these factors. But I probably want if I, because what happens when these are doubled up? When it touches the x-axis, the pass through bounce. It bounce good. And you want it to be below, so I probably want A to be negative. So this is the alteration I'm going to do. Negative squared, squared, squared. There you go. So you just have to think a little more critically about that. Does that make sense? I approach that one. Okay. Then some multiply matrices. You should know, like for example, something like this here, like you should know that both arrows point up. You could probably factor in x squared. I think there might, I don't think we're gonna have you graph lines. I think we're just gonna ask you questions about it. So just make sure you know how to analyze the polynomial function. Just look at your notes for that. Then multiply matrices. And then I think we're done. So this is a 2x3 with a 3x3. So it can be done because those line up. Let's get a highlighter here. Okay, so what does that mean? Why did I highlight it like that? What does that indicate for us? You're going to do 3 times 2 plus negative 2 times 1 plus 0 times 8. So that's going to be 4. I'm actually going to write it over here because I don't have space. Okay, then what would you do next? You guys remember? You do that next. So what happens is that's row 1, row 2, column 1, column 2, column 3. So this right here was a product of row 1, column 1. This right here would be the product of row 1, column 2. This right here would be the product of row 1, column 3. So you kind of rinse and repeat. So I'll just do it one more time just so you guys get the hang of it. And then I think you guys will be fine. Then once you exhausted all of row 1, the left matrix, repeat the process of row 2 of the left matrix with column 1, column 2, and column 3 of the right matrix. But just show you row 1, column 2, you have 0 plus negative 62, all right, minus 62, plus 0. So you get negative 62 here. And you just keep going the motions again. So, okay, I think it was a pretty thorough review. I think it's been about half our last class, and I just did that right now. Oh, one more thing. Let's look at 60 really fast. How would you write this one here? What would you do here? F of x equals what? X. Now, this is, I don't know what how I taught this to you guys before. You could do this. Actually, don't write this down because I have a better way for you guys. But you guys see what I'm doing? What I'm doing is I'm doing the conjugate, right? Negative 6 minus 5. I'm doing minus that. The FOIL, that's kind of a pain. So here's what I recommend you do. The linear terms are easy. Leave it like that. Totally fine. Here's what I do. X equals negative 6 plus minus 5i, right? Because that had to have happened. By the way, imaginary zeros have to come in pairs because we're told it's a polynomial. Polynomial assumes all coefficients are real. You're not going to have imaginary coefficients. That can't happen. Well, guess what? This is true, right? Wouldn't you agree? Then this is true. If I square it, why not? X squared plus 12x plus 36 equals, and then that's 25, negative 25, my bad. Because guess what? You square positive or negative, that becomes positive. Square 5 is 25. Well, what's I squared? So you get -25 and bring it over to the side. That's so much better than trying to FOIL it. I much prefer doing it this way. And bring it back to the fold. If we do ask you to put in standard form, just do it. Just deal with it. I know you guys will be fine. But that's a big one, just being able to figure that out, right? And I think I showed you a way it's more efficient than just foiling, x minus parentheses negative 6 minus 5 by and x minus parentheses negative 6 plus 5 by. It's just crazy. Why should we do that, Let's not do that. So that's 61 like that.
Why did it change from plus or minus to just positive?
Because you square a positive or negative, it comes out as positive
Oh,
regardless. That's why. Okay. I think I've been pretty thorough here. So you guys have pretty much seen, I kind of cherry picked some problems, but problems that I feel are good for you to study and to have more to do. So just work on it. It's your chance to work a bit. If you have APs or you're exhausted or you got paper to write, that's fine too, because it's time to do that. Again, office hours, I'm here. Tomorrow doing office hours. Y period, if you want to come Y period tomorrow, that works. Friday, office hours at the end of the day, but I won't be here. But I'll plan on doing a Zoom call. I might do 2 different Zoom calls. Yeah, so anyway. And the final for seniors, you want to do it Monday? You want to knock it out? Cool. Otherwise, we'll do in class Tuesday, Wednesday. All right. I think that's it.